So let's look at the first one. What will it say? It is asking the question. It says, please calculate the product of these two things. Okay, I do it, I am told. I will calculate the product of cosine theta 1 plus I cosine theta 2 sine. Sine theta 1. That's e to the I theta 1, right? So that corresponds to this. The other factor times the other factor, cosine theta 2 plus I sine theta 2. Okay, what does that come out to be? Well, again, we'll use the method of grouping. What's the real part of it? The real part of it is cosine theta 1, cosine theta 2. And then there's a real part which comes from these two factors. It's going to occur with a minus sign because of the I squared, and what's left is sine theta 1, sine theta 2. And then the imaginary part, I'll factor out the I, and then what's left I won't have to keep repeating the I. So it will be sine theta 1 cosine theta 2. And the other factor will be cosine theta 1 sine theta 2 plus sine theta 2 cosine theta 1. Well, it looks like a mess, but again, high school to the rescue. What is this? The top thing is nothing in disguise, but is a disguised form of cosine of theta 1 plus theta 2. And the bottom is sine of theta 1 plus theta 2. So the product of these two things is this, and that's exactly the formula. In other words, this formula is a way of writing those two trigonometric identities for the cosine of the sum and the sine of a sum. Instead of the two identities taking up that much space written one after the other, they take up this much space and they say exactly the same thing. Those two trigonometric identities are exactly the same as saying that e to the I theta satisfies the exponential law. Now that's, people ask, what's beautiful in mathematics? To me, that's beautiful. I think that's great. Something long turns into something short, and it's just as good, and moreover connects with all these other things in the world, differential equations, infinite series, blah, 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 blah. Okay.